In this video, we will be looking at the formula for angle between the line and the plane. Now let us consider a line 2x plus 3y is equal to 2 in the space, and let us consider the plane y plus 3z plus 2 is equal to 0. Let us also consider the perpendicular vector to the given plane, that is equation 2, perpendicular vector of equation 2. We get a vector. So if we see, this vector is perpendicular to this blue plane. So let's see what is the angle between the line and the plane. So the angle between the line and the plane is, in this case, it is 10.1 degree. So let's not concentrate on the number too much. Just by looking at the figure, we can see that if we actually place it over here, suppose theta is going to be the angle between the plane and the line, then if we think about the angle between the normal and the line, it's just going to be 60 degree. Right? So if this is 30 degree, then this is also 30 degree. Think that we'll be bringing this normal vector over here. So this entire is 90. So if this is 30, then this is going to be 60. So whenever theta is the angle between the line and the plane, then the angle between the normal vector and the line is going to be the complementary angle of whatever we saw here. Right? So the angle between the normal and the line is nothing but the angle between, the complementary of the angle between line and the plane. So now let us try to get the formula for the angle between the line and the plane. So we have an equation here, a line here. Then the equation of the line is going to be r vector is equal to a vector plus lambda times b vector, where a vector is an arbitrary fixed point or a fixed point in the line, and b vector is a vector parallel to the line. And the equation of the plane is given by r vector times n vector, that is equal to t, where n vector is a vector normal to the given plane. Okay, so whenever we have theta over here, then this entire angle is going to be equal to 90 minus theta. Right, so for now, let's just call it as phi. So now we know that cos of phi is going to be equal to b vector dotted with n vector, the whole upon magnitude of b vector times magnitude of n vector. Right. So, but what is phi here? We know phi is 90 minus theta. So we have cos of 90 minus theta is equal to b vector dot n vector, the whole upon magnitude of b times magnitude of n vector. But we know that cos of 90 minus theta is nothing but sine theta. So we have sine theta is equal to b vector times n vector, the whole upon magnitude of b vector times magnitude of n vector. So this is the angle between the line and the plane. So we can obtain the angle by taking sine inverse of this whole thing. So we know that already. So this is in vector form. Angle between a line and the plane in vector form. So our next step is to find the equation of angle between the line and the plane in terms of Cartesian form. So the equation of line, we can consider it to be x minus x1 by L is equal to y minus y1 by m is equal to z minus z1 by n. And we know that equation of a plane in Cartesian form is ax plus by plus cz plus g is equal to 0. So here L, m and n are direction ratios of the line, and A, B, C are direction ratios of normal of the plane or normal to the plane. Normal to the plane. So with this knowledge, we can actually substitute these values in the previous formula. We can write sine theta as AL plus BM plus Cn, the whole upon root of a square plus b square plus c square times L square plus M square plus N square, where LMN are DRs of the line, that is direction ratios of the line, and ABC are the direction ratios of the normal to the plane. Now let us look at the two special cases. The first case is when the line is perpendicular to our plane. So if it is perpendicular to our plane, that means it is going to be parallel to our normal to the plane. So whenever the line is perpendicular to the plane, that means the line is going to be parallel to the plane. So we are writing B vector because that is a vector we have considered for this particular line to be parallel. So this implies I can write B vector is equal to lambda times n vector. So this is in vector form. So if we are trying to write it in Cartesian form, we would be having A by L is equal to B by M, which is equal to C by N. This is the vector form and this is the Cartesian form. Now the second case is when the line is parallel to our plane. So when the line is parallel to our plane, what happens to the, the relationship between the normal and the line itself? So whenever the line is parallel to the plane, it is actually going to be perpendicular to the normal vector. So that is, our B vector is perpendicular to N vector. So if two vectors are perpendicular, that means that their dot product is going to be equal to 0. So this is a vector form. Yeah, that means there is a Cartesian form also, that is AL plus BM plus Cn is equal to 0. So this is a Cartesian form condition for a line and a plane to be